Now, my generation has been inspired by a guy who spoke on TV about billions and billions of galaxies far, far away, called Carl Sagan. And he really was an inspiration and a very great popularizer of science, number one, of astronomy, number two, and then, of course, of the cosmos. And he basically said, by examining other worlds, their weather, their climate, their geology, their organic chemistry, the possibility of life, we calibrate our own world. We learn better how to understand the Earth. And those were wise words. That's essentially the science case. Arthur C. Clarke, who was a very famous science fiction writer, as you know, he wrote 2001: A Space Odyssey, said, the reason for going to Mars is for the science, for the challenge, and for the future. Well, and that pretty much sums up the whole case for going to Mars. Adriana Marais has a very impressive CV. She studied theoretical physics and philosophy at UCT. She was awarded a Master in Science in Quantum Cryptography at the University of KwaZulu-Natal, and a PhD in quantum biology, also at the University of KwaZulu-Natal. She was one of the 15 recipients worldwide of a 2015 L'Oreal UNESCO International Rising Talent Grant for Women in Science. Congratulations. She was awarded the 2016 Royal Society of South Africa Meyring Naudé Medal for Young Researcher. She was invited to attend the 2016 Lindau Nobel Laureate meeting as one of the most qualified young physicists in the world. Since childhood, Adriana has dreamt of living on another planet. And at this moment, she's on the list for the Mars One project. Elon Musk said just last week that in 5 years' time, his Earth launch and Mars landing rocket can fly. So the time is short. Thank you very much indeed, Adriana, for spending time with us.
Thanks so much for that great introduction. My mic on. Can you hear me? Yes. Good. I feel like after talking about dates in the 2020s and 2040s, that's a good trajectory to the next topic, which is space travel, because these are typically the dates that we're looking at. And I think I can't emphasize enough what an exciting era this one is that we are living in, because I believe, and let's say the window is rather large, it could be as close as 5 years, it could be as much as 20, but I believe within that period, we will see the first humans landing on the surface of Mars and setting up a research station and furthermore a society, the first of its kind, the first movement of a species from one planet to another that we're aware of. So I've got a large range of topics to talk to you about today, and I'd love to go into detail on all of them, but I won't have time. But I think as a focus, I'd like to focus on three biggest unknowns. What are, in my mind at least, the three biggest sort of unsolved problems that we have in science and as humanity indeed. So the first one is this proof, which is a fairly elegant piece of mathematics, but a lot of people don't understand it. So, no, I'm joking. This is actually the first theoretical mathematical proof of quantum encryption, but that's not one of the big challenges that I'm talking about. So one of the biggest unsolved phenomena or not fully understood phenomena in the world, in the universe, in my opinion, is life. So arguably we understand the origins of the universe better than we do the origins of life. At least we have a mainstream theory, the Big Bang theory, for how the universe emerged. How life emerged and what exactly life is still somewhat of a mystery. So I think we've all wondered these questions as humans, and the question of what is life is both a question that we all have as well as a deep sort of scientific line of investigation. So my research in quantum mechanics has actually taken me to the study of life, because if we try to break things down, quantum mechanics is really the theory that's at the heart of everything. It's our most fundamental theory of reality. So if we want to break things down, we're going to break them up into the smallest constituents that we know of, and those are quantum objects. So interestingly, it was actually a lecture by Niels Bohr, one of the fathers of quantum physics, that is said to have inspired the advent or the creation of the theory of molecular biology. So in the audience in Niels Bohr's talk back in the 1920s was Max Delbruck, who was fascinated by Niels Bohr's proposal that some crystalline, he thought, some crystal or some information container must be passed on from generation to generation in order to have the continuity of a species that we see in various species. So he was kind of the first proposer of something like DNA that potentially carries information from one generation to another. Max Delbruck was in the audience and went on to establish the field of molecular biology and win a Nobel Prize for that. So that molecule there, the DNA molecule that kind of maps the sort of few nanometer wide, meters long, but few nanometer wide scale of things, is kind of the transition between where classical physics describes, well, what's going on, and where quantum physics describes what's going on. And there's a huge body of research now looking into how potentially random mutations and replication in DNA could have quantum mechanics as some part of the explanation on how that works. So this is then one of the greatest achievements of trying to break things down into their smallest component, this discovery that all life on Earth has this molecule in common. So maybe that's the grandest achievement we've made so far in terms of understanding what life is. At least we know that all life on Earth has this molecule in common, the DNA molecule. But besides this commonality, and in fact that molecule has shown us, and studies in genetics have shown us, that all life on Earth emerges from a last universal common ancestor. This is the theory. So we're all related, and the study of life on Earth is limited to, therefore, a single data point. And this is not a very informative way to study a phenomenon with only one example of it. So we haven't made much headway in answering this question, which is, what exactly is it that makes a living system different from the atoms and molecules and inanimate matter that it's constituted of? Because we can hopefully all agree that we're made up of molecules, that are made up of atoms, that are made up of the fundamental particles that make up atoms, but we are also very different to a pile of carbon, hydrogen, nitrogen, and all of the different atoms that we are composed of. So looking into the very small parts of living systems, we could start with the most simple living systems that we know of, which are single-celled organisms. And that's a picture of the bacterial reaction center. And it's now mainstream scientific understanding that we cannot understand the photosynthetic process in bacteria, and probably also in higher plants, because they share this similar structure of the reaction center in common. We cannot understand the process of the electron. Those little arrows are just showing how the electron transfer process creates the battery, the charge-separated state that powers the rest of the photosynthetic process. We can't understand the movement of that electron on such short time scales, picoseconds, without invoking quantum mechanics. So therefore, plants, probably, and certainly bacteria, harness quantum effects to optimize their efficiency in terms of converting sunlight into electrical potential energy. So that's the most simple living system that we can imagine, bacteria, and there are still large gaps in our understanding of how that works. So when we go up to try and understand general life, or indeed the human brain, which is possibly the most complex entity within living systems, we of course don't have a full understanding of that yet. So I would have to mention some very interesting progress towards, and I put a question mark there, synthesizing life at the Craig Fenter Institute. So Craig Fenter, known for having accelerated the mapping of the human genome by 2 years, because he took the project on board himself and then became the first human to have had his genome mapped, has gone on to make a minimum viable cell. So I put a question mark there because the cell itself was not synthesized. We have not yet figured out how cell wall and all of the components of a cell can spontaneously form in a kind of chemical way in the laboratory, in laboratory conditions. But they have taken an existing cell and inserted synthetic DNA into that cell. It's viable as in it lives. That's what it looks like. And the DNA that they inserted is completely synthetic. So from their understanding of what different portions of the genetic code do, they put those in and made this what they call minimum viable cell with some few hundred genes in there. So you can Google more on that if you're interested. That was last year. So we haven't managed to synthesize life. We haven't managed to understand how it formed, although there are sort of some theories on that. Interestingly, we have detected fairly complex molecules in space. So in our own galaxy, and excitingly, the SKA, amongst its scientific aims and objectives, would be to look for complex molecules, including molecules that are building blocks of life. And we have already had a detection a couple of years ago of glycine, not coincidentally the simplest amino acid, which therefore has a spectral signature which is less complex than other bigger amino acids, has been detected in our galaxy. Not on the surface of a planet or in an atmosphere, but in an interstellar cloud. So these clouds are at very low temperatures, and it's surprising that such complexity could have formed spontaneously at such a low temperature. So there's a body of research going on in that direction, which I would like to call quantum astrobiology, because astrobiology is the search for life out there, and it turns out we need, of course, quantum mechanics to understand the spectra of these molecules and to understand the dynamics involved in the formation of these molecules. So astrobiology could be the clue that we are looking for in terms of finding another data point, another set of living systems. I think there are several options here. So if we were to find life on Mars, it could either be DNA-based or not, or we don't find any life at all. But I think those are the kind of the three options. So the most exciting one would be if it's not DNA-based. That would mean it would probably be difficult to classify it as life at all, but we would have several measures to try to do that. But if it is DNA-based, that's also fascinating, because that would mean we're related, that potentially life on Mars seeded life on Earth. There's a lot of meteoritic exchange between the two planets, tons and tons and tons on an annual basis of rocks fall, and some of them come from Mars. So that could be possible, but we really do need to find, I think, at least another set of living systems somewhere else that we have two data points from which to try and draw some conclusions about the fundamental principles of life and how it may have emerged. So Mars is a natural candidate, being just 10 light minutes away, and of course we have done some exploration of the surface, which I'll get to in a moment. If we start to look further out, the nearest star is 4 light years away. So Skyview is a fantastic app that you can use day or night, and much cheaper than a telescope. It's free to find out where different bodies are in space, whether it's Mars or Alpha Centauri, the closest star. Sorry, Proxima Centauri, the closest star to our Sun. And there have been planets detected in orbit around the star. So it's only been in the last few decades that we've been detecting exoplanets. For many centuries or millennia even, we may have believed that our planet was the only one, or that the wanderers, that were these anomalous lights in the sky moving around, were finally identified as planets, that these were the only ones. But now we've started to identify more and more planets. And interestingly, these planets in orbit around Proxima Centauri may even be in the so-called Goldilocks zone, which we can estimate due to the intensity of the star and the distance from it, may be able to host liquid water on the surface. Before the planets that detected in orbit around Proxima Centauri were detected, Kepler 452b was the most exciting candidate for potentially having liquid water, and this having liquid water, of course, doesn't imply the existence of life, but all life that we know of needs water, so that could be a good place to start looking. So this is an artist's impression, of course. We haven't got that high-res images of it yet, it being 1,400 light years away. So even if you speak to 10-year-olds and come up with some strategies, which are not that crazy because they're the same ones that NASA has, to get to such a planet, which are hibernation or intergenerational travel, and 10-year-olds literally do come up with these ideas themselves. If the people that arrived on Kepler 452b sent a signal back to Earth to say, we've arrived, the place is teeming with life, it's fantastic, you should come and look, that message itself would take 1,400 years to travel through space back to Earth. And that's a bit of a problem. So we are waiting for a revolution in theoretical physics whereby we can go faster than the speed of light. That would be fantastic. It is, of course, just a theory, but it's been a theory for a while now. We have no evidence to the contrary yet. Some exciting proposals in terms of wormholes and other things, but so far that's all in the space of science fiction. Although many of the things I'm going to mention were science fiction, now science fact. So we really do need to overcome this upper speed limit in order to make a meaningful exploration of our galaxy and galaxies beyond, because the nearest galaxy, 2.5 million light years away, that's Andromeda, there is some kind of edge beyond which we can't see. It's opaque. That's kind of a comforting thought, because it's nice to have an edge, or no, some people might disagree. degree. But that's 47 billion light years away, so we do have a lot of empty space in between to explore. So the point of the slide is basically to remind you the universe is huge, we know that, but also that Mars is really a natural candidate for exploration and for the search for what for me is the most important question of all, and that's understanding who we are. We are living systems, and to try and understand our place in terms of being a living organism in this universe in which we find ourselves. So that brings me to the second big unknown, and as a good physicist I will reference that space-time, those four parameters together create the continuum that underpins relativity, special relativity, and general relativity. But if you'll allow me to break it up, so I'm going to talk about space first, in the meaning of the space in which we find ourselves, so the local solar system and beyond. So in order to understand life, we're going to have to start exploring space, because we need to find another data point, as I've said. So just a bit of history of our exploration of space. Konstantin was actually a mathematician, an astrophysicist, a rocket scientist, the founder of rocket scientists almost, but also a storyteller, more as a pedagogical method than as a science fiction writer, but he envisaged the first rockets and the first satellites before they were actually created in the 20s and 30s and 40s in Russia. And then 22 years after he had proposed the satellite, the Russians actually did launch Sputnik, the first satellite launched into low Earth orbit in 1957. After that, of course, we had the Apollo era of moon landings, and interestingly, there was a spike in students doing science, technology, engineering, and mathematics PhDs, not only in the US, but worldwide. And what did we see after that? The mobile phone, personal computer, the internet. All of these technologies emerged, and there are correlations as a result of the inspiration of seeing people go further than they've ever gone before, doing things that we thought to have been technically impossible, and achieving these goals. It was unfortunately war-driven, but I think it does show what potential we can reach when we put our minds together to achieve goals that have never been achieved before. So we've continued in this grand era of space exploration with, of course, humans haven't been back to the moon since 1972, so we have now got good at doing remotely operated remote missions, uncrewed, of course. So Cassini, you probably heard, was decommissioned, as in deployed into Saturn's atmosphere and burned up on entry into the atmosphere. And that was since 1997. So someone wrote a great tweet on this, that we watched the launch of Cassini on television, we followed the progress on our computers, and we watched the end on our mobile phones. So that shows the development of technology that's happened while Cassini was out in the outer edges of the solar system exploring Saturn and its moons, and the potential for some of those moons to actually harbor liquid water and therefore potentially life. So you might wonder how liquid water could be sustained so far from the sun. So it's the gravitational energy, so the shrinking and flexing of the planet itself, or the moon itself, sorry, with respect to the large gravitational field of Saturn, can actually create heat, which could maintain liquid water under the surface of some of these moons. So exciting stuff, which you can see a lot of detail on now, since it just ended a few weeks ago. So I think my favorite science achievement, besides the internet, is the Curiosity rover. That's the 7th time that we've landed successfully on the surface of Mars. And the Curiosity rover has a laboratory on board, the ChemCam, possibly one of its coolest instruments, which is a laser which fires into a rock to disintegrate the surface of that rock and then apply spectroscopy to understand the composition of that rock, as well as using imaging of the parent body to get quite an accurate analysis of what that rock contains. It analyzes the composition of the atmosphere, the sand, as I've said, the pressure, the radiation, temperature, all of the kind of characteristics that we'd need to know about in detail if we were going to send humans and all the technology that they need to survive to this planet 200 million kilometers from Earth. So indeed, the Mars One project is not the only one to have announced plans to send crews to Mars, and if you were following the International Astronautical Congress in Adelaide, which we had mentioned, you would have heard Elon Musk's latest update, which is that they would not be sending a cargo mission in 2018, but rather in I think it was 3 years' time, but I heard 5. Double check that YouTube video, that's just out now. So that would be the SpaceX cargo mission. They would then become the first private company to land a cargo mission on the surface of Mars. So far, NASA has been the only entity to achieve that. ESA has failed a few times. Then we would be on track for, let's say, pre-2030. I mean, these dates always have to be taken with a pinch of salt. A pre-2030 crewed landing is then not impossible. So Elon Musk and SpaceX are not training or selecting any crew as of yet, and have no plans to, according to certain statements made. So Mars One is then well positioned as the only entity on Earth that's selecting and training crew, and I'll talk more about the Mars One project in a minute. NASA has announced plans to send crews to Mars, but of course operating on government cycles, which are several years. This fluctuates, and recently we've heard an update that they do no longer plan to send crews to Mars as it's too expensive. I think this is an interesting transition from what was previously government activities into the private sector, and this is a good thing. Of course, we still have the history and the knowledge and skills of NASA over the decades, being the leader with, of course, the Russian space agencies, European space agencies, Japanese, Indian space agencies. However, a collaboration between private industries and institutions, I think, will be the way that we will get to Mars this time around. And I think it will be collaboration at the end of the day. We've got Lockheed Martin planning to send humans, Boeing claiming it wants to beat SpaceX, and we have Mars One, which is summarized here in this video.
I want to go to Mars not just to be a part of history, but to inspire people around the world.
The colonization of Mars is the adventure of the century.
This is our chance to get the world excited about space again.
If we can look up from Earth and know that human beings are living on another planet, will we ever again be able to tell ourselves that there's anything we can't do?
I want to contribute directly to mankind's confident expansion into the solar system, which we have to do if we're going to survive in the long term.
I believe it is in our nature and it is our destiny.
I want, after I die, the impact of my life is imparted upon those who follow.
I know it comes at the cost of living Earth forever, but future belongs to those who believe in the beauty of their dreams.
So that is actually accurate. It will be coming soon to a screen near you, because the funding model for the mission is actually that a globally watched event can generate on the order of magnitude of money required to send crew to Mars. What order of magnitude are we talking? $10 billion US. You could probably multiply that by a few factors, but in the tens of billions of dollars, let's say. And the London Olympic Games generated $8 billion US in viewership, advertising, etc., broadcasting revenue alone. So it is possible that with our 7 billion people, with all of their devices, that we can actually generate the costs required to send crews to Mars by the reality documentary series. I prefer the word documentary, but some people prefer the word reality. But we'll basically be, recording our selection process, the training, the 10 years of the technology development and the training before the departure of the first 4. So the 10 years of training, I think, is not all required. That's more for the development of the tech. So if SpaceX develops the rocket sooner than we hoped, Mars One plans to outsource all of their technology. So entities like Lockheed Martin, Boeing, Airbus, SpaceX will be contributors to the total mission. Or perhaps we could hitch a ride with the SpaceX mission to Mars, because as of yet they haven't announced any plans to select or train crew, as I've said. So let's call it around a decade, all technology outsourced, and the project funded by all of you. There are 100 of us left, 3 from South Africa. If you're interested in who these people are, you can check the videos that we uploaded on the website. I'd say the characteristic we have in common is perseverance. So we've been in the program for 5 years now. So this is really a sense of purpose that we share. We don't plan to end our lives on Earth and start a new life on Mars. We plan to continue what we've been doing here on Earth on Mars. So what kind of crazy people does that make us? Well, engineers, researchers, software developers, the kinds of people who believe that the skills that they've spent decades acquiring on Earth will be useful and necessary and beneficial to a new society on the surface of Mars. You can also invest. We're listed on the Frankfurt Stock Exchange, or you can happily watch the documentary series too. So the Curiosity rover, as I've said, one of my favorite science achievements, has given us a lot of information about what we can expect in terms of the conditions on the surface of Mars. So a day on Mars, called a sol, if you've watched The Martian, you would be familiar with that word, is just sort of 40 minutes longer than a day on Earth. So in terms of adjusting to the diurnal cycle, we are already doing studies on that with the ground control teams that are monitoring the experiments on the surface of Mars, which adhere then to this Martian day. It's 40 minutes longer than a day on Earth. The reason Mars is red is the iron oxide. So just like Earth, iron is a large component of the surface sand. I'll talk about extracting resources from that surface in a moment. Gravity on Mars is about a third, just more than a third of the gravity on Earth. So that means construction, moving around, these kind of activities will be easier than they would have been on Earth, although we'll of course be wearing suits when we go outside. So all in all, the weight of the oxygen tanks and so on would probably give you a similar experience to walking on Earth as you would on Mars with the suit on. Why do you need a suit? First of all, the temperature is negative 63 on average. Let's call it negative 50 on average. It can go up to the 30s, but basically it's on average below zero. Mars has a very thin atmosphere. The pressure is less than 1% of the pressure on Earth. So that would probably be the most noticeable difference between the environments here on Earth and on Mars, is that even if there were oxygen in the atmosphere on Mars, which there's not, it's 96% carbon dioxide and argon and other gases, no oxygen. Yeah, so either the pressure, the lack of oxygen, or the cold would kill you pretty quickly, probably in a matter of seconds, unless you're wearing a suit. The distance to Mars is around 200 million kilometers on average. So the time delay of light traveling between the two, as I've said, is around 10 minutes. And it takes currently around 7 months. The Curiosity rover took a journey of 7 months to reach the surface of Mars, so we could expect that to be reduced to a few months in the coming years. That's approximately...
It's March 30th, 2017, 6:08 p.m. Eastern, 10:08 p.m. UTC. You're looking at a live view of a recovered Falcon 9 rocket on the SpaceX launch pad as it awaits its second launch since landing back in April 2016.
So I never get tired of showing this video, and before I talk about the tech required to take humans and sustain them on the surface of Mars, we have to look at the words of the NASA shuttle manager just months before this was achieved, that this would be impossible. This was achieved by South African-born Elon Musk. This is the second time this rocket's been launched. So to demonstrate reusability, it's not just enough to land the rocket. You have to launch that same rocket again and land it again. Then reusability has been completely demonstrated. So what you're seeing here is the separation of stage 1 from stage 2. There's the speed of stage 2, which is delivering satellites to low Earth orbits. Stage 1 is separating and returning back to Earth to land on a remotely controlled drone platform hundreds of miles out into the Atlantic Ocean.
First stage on its way back to the drone ship in the Atlantic Ocean, slowing down as it heads through the atmosphere. Second stage continues to be on target. Propulsion looks good. Everything continues to be go.
So SpaceX has actually launched more times this year than any other space agency, and I think this is a clear example of how the private sector is outstripping, in terms of funding and activity, government agencies at this point in time.
Hi, well, we just had an incredible day today. The first reflight of an orbital-class booster did its mission perfectly, dropped off the second stage, came back and landed on the drone ship right in the bullseye. It's an amazing day. I think it's really a great day, not just for SpaceX, but for the space industry as a whole, and proving that something can be done that many people said was impossible. Thank you.
So that was after 4 failures, SpaceX was nearly bankrupt. Sort of Tesla had to carry it through for a while there, and that shows that dedication and not giving up can be the key elements to success. And as I've said, this is now an analogy for how I think technology will develop in the next 10 years. Looking back, what kind of technology we had 10 years ago, or even at the technology that they used to launch crew to the moon. I mean, we didn't have the capability to do remotely controlled missions in those days. We had to send crew, and to see how far we've come since then. I think anything is possible. We don't need a quantum computer. We don't need a revolution in propulsion systems in order to get the crew to Mars. We just need large teams, large budgets, and a belief that we can do it. So this is the conference in Adelaide. Do watch the YouTube video if you want to hear the updates from Elon Musk. So that is the big rocket, the BFR. This will be the biggest rocket that we have ever used. This is the idea to send the first cargo and crews to Mars in the coming years. By a private company, SpaceX. So as I said, Mars One would outsource all technology, so we're all watching keenly on the progress of SpaceX to get the propulsion systems right. The transit habitat, crucial. That will be 7 months at least, or at the most, 7 months of our time will be spent in there. And you can see why you need such a big rocket, because the water alone is 3 tons of water. So that's just drinking water for 4 people. That's sitting at like 2.5 liters per person per day. So really the minimal. I'm sure you know there's no bathing or anything, or wet wiping. So being in Cape Town is obviously good practice for going to space lately. But 3 tons of water for 4 people. That's, and then 700 kilograms of oxygen. That's the oxygen that 4 people would breathe during the 7-month journey. Almost equivalent to the weight of the food that we'd bring. That would be dehydrated. Some of the water would be used to add to that. The water would also be used as a radiation shield, the wastewater as well. So we'll be surrounded by a protective layer of water as we potentially encounter solar flares on the way. That's the most vulnerable point that you're at, is when you're in between planets. You've got no atmosphere to protect you. Even the thin one on Mars is better than the metal shell that surrounds you on the way there. So that part would be crucial to get there safely, of course. Landing, even more dangerous than the transit. We have had several failures in terms of landing on the surface of Mars, 7 successes, although since 2000 we've succeeded in around 80% of landing missions to Mars, so we're getting better. The rovers would be sent to Mars ahead of the crew. These would be the Mars One rovers to scout for a location, to start to level the ground and start to set up, remotely controlled, the habitat that we'll live in. The satellites are obviously crucial. These would arrive before the rovers, and 2 of them, one aerostationary, that's like geostationary but above the surface of Mars, the other one in the orbit around the Sun. So I think every year there's some seconds where there's lack of communication due to being blocked, but 2 satellites is the minimum required there. So will we have internet connection on Mars? Yes, we'll be sharing 2 satellites between 4 people initially. On Earth we share, 1,400 between 7 billion, so yeah, we'll have good connectivity. 10-minute delay, of course. And Google was already talking about the interplanetary internet a few years ago, so we will of course be in communication. If you've seen The Martian, you know how crucial communication is, and we'll be able to upload video clips and exchange messages in that way. So the landing, importantly, so Lockheed Martin designed the landing gear for the moon, or one of the contributors. They have been under discussions with Mars One to potentially design the lander for Mars. So these are all potential relationships that I'm mentioning here now. Okay, Paragon Space has written a detailed life support study. That's a sort of 40-page PDF, which you can look for on the Mars One website if you're interested. The life support system is the habitat where we'll be living. So how we will go about recycling. First of all, the water that we drink will be extracted from the sand. there's H2O in the surface of Mars. There were once oceans on the surface of Mars, it looks as though, due to looking at the canyons and the pebbles, other features in the geology that we can only associate with liquid water having been there, coastlines as well. So some of that H2O remains, and we can extract it, melt it, condense it, and purify it and store it in tanks. Before the humans even arrive, there will be several thousand liters of water stored in tanks waiting for us. Where will the oxygen come from that we pump and pressurize the living units with, at 21% obviously, from the H2O, electrolysis, to break up those, the H2O molecules. And what do you have left? Hydrogen, which is the basis for certain techniques to make rocket fuel. So H2O is really a truly valuable molecule here for the life support, and I'll talk a bit more about that in a moment. So this is the living area. It's just artist's impression, obviously. We will grow food, so we'll bring 2 years of food with us, and the next crew arriving 2 years later would bring another backup food supply with them, and it would take, according to some estimates, around 2 years to be able to generate enough kilojoules from the garden to feed the 4 people that will be tending to that garden. I'm sure there will be a lot of competition over who will get the hours in the greenhouse, because that's going to be the closest sort of place to home, would be that green area where we grow our food. We'll have an entertainment area, but more than that, that's the screen by which we'll communicate with teams on Earth and family and friends. We'll have bedrooms, private bedrooms. We'll have laboratory facilities, medical facilities. I'll talk a bit more about that in a moment. There's the close-up. So I think I'm going to talk about a few technologies now, but I think the kind of technologies that we view as innovative here on Earth will not be innovative on Mars. They'll be absolutely crucial. Or ideas like smart farming, vertical stacked, where you use data to optimize the output of the nutrition that you require in the minimum amount of time with the minimum amount of resources. We're seeing these kind of developments being necessary on Earth, especially in Africa, where we are the fastest urbanizing population. Half of the population growth on the planet that will happen between now and 2050 will be here. So we're going to have increased numbers of people living in urban areas. We're going to need to start producing food in urban areas. And this is an attractive method on how to do that. Maybe you saw the Carte Blanche episode on vertical farming. Very interesting. Using data, of course, to optimize that. So I've talked about the surface sand of Mars containing water. That will be our source of water, hydrogen, and oxygen. But also the volcanic features and cratering indicate that the kind of minerals that are created under these heat impact conditions will be found on Earth and also on Mars. So we can extract these resources for our 3D printers. 3D printing is absolutely going to be a crucial technology to sustainability on Mars. If you forget your toothbrush, you can 3D print a new one, and various other tools that are required. 3D printing, eventually, being able to print circuit boards, being able to print components for the habitat, being able to, create fuel propellant, of course. That would be the aim. Yes, it's a one-way trip that we volunteered for, but of course, one of our main priorities would be to set up a ground control station, launch pad, facilities whereby we can also launch back to Earth or back to some vehicle to rendezvous with, which is en route back to Earth. So I'm going to now run through some other technologies, and then I'm almost done towards the end. But can we grow food on Mars? Well, we can grow food, we can grow plants in the International Space Station, so there's no reason why we wouldn't be able to grow them in the conditions that are livable by humans inside the habitat on the surface of Mars. And the first flower indeed bloomed in the International Space Station last year sometime, I think it was. So telemedicine is standard on the International Space Station, and Scott Kelly spent a year with Mikhail Koryenko, who I had the pleasure of meeting actually. 1 year, that's the longest continuous time spent in the space station. All of their bodily fluids were collected and then sent back to Earth for analysis. So there was one massive payload of both of their stuff coming back down to Earth, but this is part of the process of understanding the long-term impacts of being in microgravity on the human body. Mars will not be as extreme as microgravity, so we'd expect to find some sort of intermediate symptoms that we do find on people in the space station, so eyesight being affected due to the pressure changes in the body, and various other factors. You can read up detailed research projects on that, and I think the research coming out from Scott Kelly and Mikhail Koryenko's 1 year period is now being published, so you can look that up. 3D printing, so Made in Space, fantastic company that came out of Singularity University, has sent their 3D printer into space, and they have printed a wrench and various other tools that they have needed on the space station in the 3D printer. So proof of concept, we can 3D print in space, of course, 3D printing metals and other more complex materials is still to be demonstrated. So this is the final technology that I will mention, and I could go on about this for hours, but I'll try not to. Asteroid mining. Many motivations to start characterizing, analyzing, understanding, and potentially retrieving resources from asteroids. The first reason is impact. So I was in Russia at a mining conference talking about asteroid mining the other day, and we were very close to Chelyabinsk, where a meteorite came out of nowhere and caused windows to smash, caused some people to sort of drive off the road. Meteorite came out of nowhere, impacted with the surface, and this was not detected at all. It was around 20 meters, so this was a small one. But this just shows that there are many rocks out there with the trajectory that's coming towards Earth that we are not aware of. That's the first reason we'd want to study asteroids. The second one is to investigate the origins of the solar system, look for complex molecules that may be precursors of life. The third one is for resources in space. So the current main cost of getting to space is launch. Hence Elon Musk's wanting to reuse the rocket. That's the most expensive part. He's going to reduce launch costs by about half by reusing the rocket. But imagine if we didn't have to launch satellites from the surface of Earth into low Earth orbit. If we could just 3D print nanosatellites in space using resources from space. So these are very interesting figures that we looked at some articles. I can give you the details on those afterwards if you like. This was part of our presentation. So currently, and this was done by a terrestrial and earth mining company, the cost for extracting metals or whatever resources you're extracting is around $542 US per ounce. I don't know how the States was acquired, but that was the number by the mining experts. So then we took an article written on the estimated costs of retrieving an asteroid into low Earth orbit. So this is just cost. This is not looking at profit or what you're extracting at all. The first time you do it will cost around $819 US per ounce. The second time you do it will be cheaper than extracting resources from the surface of Earth. The low-hanging fruit on the surface of Earth is gone. I mean, the Ipponing mine is now 2 kilometers deep, and they're still going deeper to try and look for more metals, which are no longer found at the surface, but increasingly difficult to get to. The costs of restoring the environment subsequent to digging up the resources that we're trying to extract is another cost. Labor costs, the fluctuating price of gold, all of these are factors that mean that extracting resources from asteroids may soon be cheaper than extracting them on Earth. Again, there's no revolution in science required to implement this. And we looked at the SHEPHERD mission. If you want to look that up, SHEPHERD, it involves encapsulating the asteroid completely and using gas mining, so chemical reactive processes with different gases to extract, to disintegrate and then distribute and the different resources that you would extract from there, including iron, platinum, you name it. What you find on Earth is somewhere out there in an asteroid, surrounded by not bedrock or Earth crust, but vacuum. So I think that's definitely the way forward in terms of extracting resources for long-term space missions. Imagine rendezvousing with an asteroid which has a mining contraption device on it, where you can refuel on water, which can be turned into fuel, where you can collect different metals that you may require to 3D print different components on the mission that you may need to. So that's the future of space exploration, I believe, is being able to extract and use resources from space in space. So I'm not trying to make a political statement here, but this comic just keeps on giving because it's from 2015, and as I said, not a political statement, but rather an indication of how the Mars One project has got into popular culture. So we've seen Lisa Simpson volunteering to go to Mars with the Mars One project. We've seen Cartman volunteering to go to Mars in South Park. We've seen Sheldon Cooper volunteering to go to Mars on the Big Bang Theory. We see Zapiro doing political satire involving the Mars One project. So this is an indication of the insertion of this idea into popular culture, which I believe is a precursor to this actually happening. You may call it a scam, a hoax, sort of 10 years ago. Now people are starting to think more about the idea that we may actually be going. And the next steps will really be contributing and getting together as scientists, engineers, researchers on Earth to actually make this happen. So you may have an idea of some people you might want to send to Mars, but the question I haven't probably answered is like, really why? And to go back to the 3 biggest unknowns, I think. So for me, understanding life, understanding who I am, who we all are, what is our legacy. 4 billion years of evolution have resulted in us in this room right now. How can we try to understand that more deeply? And I think going into space and looking for evidence of other life forms is one way that we would make a huge leap in terms of understanding our place in the universe. So space exploration for me is the kind of pinnacle of human curiosity, the human exploratory spirits, the human imagination. And I think whether or not you agree with number 2, what we all have is life and time. And I think the biggest motivation for me of actually going to Mars is that what a waste of 4 billion years it would be if we were taken out by an asteroid impact, if we were all destroyed during a nuclear war, if some unforeseen or self-created event caused everything on the surface of Earth to disappear. Life would probably re-emerge, but it would be simple, and that would mean we would have lost those 4 billion years. So at the end of the day, I think we all agree that we've been given life and we've been given time, and what you do with the space in between is your choice. Also, if we look back in history, I think humans are explorers. So my ancestors arrived in 1688 on a few-month one-way trip into the unknown. I'm sure you can see the parallels with the mission to Mars. It may be interplanetary and not intercontinental, but it takes a period of months, and it's really into the unknown. And I think this is a good motivation, as I've been saying, in terms of not wasting that precious time that it's taken us to reach this level of complexity, that explorers will always have the means and the understanding to protect themselves against unforeseen circumstances in a way that organisms that stay in their comfort zone never will. And that's what humans do. We've covered the surface of this planet, and I don't think that's the end of our exploration days. So thanks for 6 Degrees Fulton for the presentation, and thanks so much for your time, and I'm very happy to answer questions if you have any.
Ladies and gentlemen, any questions please for Adriana? Suja.
So on the journey there for the 4 crew, there were numbers there for food and water. Does that include the possibility of having to come back to Earth because something went wrong?
No.
Really?
So the Mars One project wants to get there first. Therefore, they would like to do the minimum economic and the technical infrastructure model. So there's enough food there to last for 2 years, because that would be the arrival of the next crew. But the water, indeed, is calculated for 2.5 liters per person per day for 7 months. So, and the fuel, no.
So it's really a one-way trip?
Yeah, I mean, when I saw it advertised as a one-way trip, part of me was glad because I knew less people would apply. So, the price of being a pioneer.
Hi there, Nick Clutie-Hopkins. My question to you stems from the book Lord of the Flies, and I think about a group of 4 people in a very confined space, and I'm not saying it's not enticing, but at the same point, what's the psychology behind it, and how much are you guys having to look into your inner beings? I mean, it must be incredible.
Yeah, so I think the technical side of things, in my mind, at least as a ignorant theoretical physics, the hard work comes in actually doing the engineering with the real life conditions and making these wonderful proposals work. In my mind, that's essentially done. The questions that we haven't really answered are the psychological ones. What goes through 4 people's minds when they're 200 million kilometers away from Earth? There's a certain amount of simulation you can do to estimate, what could go wrong, but the only way you really figure that out is by actually doing it. So there are these isolation missions in the Utah deserts. Antarctica is probably a good model for the kind of isolation in small groups that one would experience. Lots of studies have been done on monitoring those personalities in that group. So the Mars One idea is that the tech would take around 10 years to develop, and during those 10 years, the same team of 4 would train together. So any disagreements that arose during those 10 years would be solved by reshuffling those people around, and that team would then fall back to the beginning of the training pool. So it's in your interest to get on with your team in order to get to Mars, but also to survive the mission to Mars. So I think the 10 years of training in that same team would help. I think the unity of purpose would help. So this is not Big Brother, where you really try on purpose to take people with completely different thinking and put them in a small space. This is people who've worked their whole life for this, who've trained together for 10 years and know their roles and contributions to the team and the essential contribution that they make to the survival of that team. So with those dynamics, I think it will be a stronger team than you might imagine. But of course, I guess that's where the interesting part of the documentary series comes in, is you guys being able to watch that process.
Hi, thank you for the fascinating talk. What does the numbers say? What's the probability of survival actually reaching Mars and making a safe landing and so on?
Well, so landings, if you look at the total landings, I think it's like 14 or 15 failures, so you're looking at 50-50, because we've successfully landed 7 times. But if you look since 2000, as I said, 80% of our cargo missions have landed successfully. So sometimes we don't know why the landing has failed. It could be that the communication system has failed, but that the landing was successful. So once we have crew on board, some of these errors could potentially be ironed out, where a near fail could become a successful landing. Yeah, who knows what the probability would be to survive. I've spoken to medical experts and said, what would the life expectancy be? It's really hard to know. We'd have factors like eating purely organic food, clean water, no germs. But then we'd also have the problem of new crew arriving, potentially with new germs. We'd have the radiation to consider. The radiation is probably the most dangerous part of the mission. Although, if you calculate the radiation exposure you'd get during the 7-month trip there, obviously the more you can minimize that, the better it is for that exposure without any atmosphere protection. But if you take that, plus 60 years on the surface of Mars, only going outside for 1 hour a day, you're still below the NASA maximum threshold for radiation in terms of sieverts. So 1 hour a day for 60 years on Mars, you could still be below the threshold. I think the threshold's calculated at 2% increase in chance of getting cancer. So not that bad, yeah. Much better than smoking.
I'm interested in the laws that you would be taking with you, and the obvious example is euthanasia. Just as an obvious example, if you would like to explore on laws or sort of rules.
You're only the second person who's ever asked that. Yeah, that's a tough one, I think. Let's say your emergency surgeon wants to be euthanized, yeah, that's a tough call. But I think obviously each person needs to make their decisions for themselves. You can't go against someone's wishes for the survival of the team. I think they would have the ultimate say for that. That's just my opinion. And the Mars One project has similar ideas. I think they are quite open in terms of everyone being able to practice their own religion, everyone being able to hold their belief system, but not allowing that to interfere with others. So if death on Mars, it's going to happen at some point. So personally, I would give up every possible molecule of my body that could be used for some useful purpose. Organs, of course, if they're intact. Biofuel, blood. All of these things will be very precious resources on Mars. So I think this will actually stimulate a greater respect for Mars, for life in the society on Mars than we have on Earth, which is teeming with life. I think sometimes we forget that this may be the only planet that hosts life. When we look at the kind of disrespect with which we treat other living things. So this will not be the case on Mars. The most simplest bacterium, the smallest ant, and of course the human will be absolutely intrinsic to the survival of the system that lives there.
Thanks for a very interesting talk. Just a question. Many of the missions so far have taken great precaution not to contaminate new environments with microorganisms and so forth. How would this play out in Mars One? Because obviously now we're actually spreading life on a new planet. Has there been any research as to what the impact would be of our organisms getting into the Martian atmosphere in general?
That's an interesting question, and probably the most important one. If I am planning to go to Mars to look for evidence of life, finding evidence of life that was brought there by the Viking landers in the 70s would be a bit of an anticlimax. This is a problem, and not one that's fully solved. So I have sat in on the planetary protection discussions with various space agencies and so on at an astrobiology conference a few years ago, and I was really impressed by the sole goal of that discussion being to protect scientific investigation. So indeed, forward contamination and not backward contamination was the main point of discussion there. The unfortunate thing is that the Viking missions were not sterilized according to the standards that we have today. So we probably have already contaminated the surface of Mars, so we can't do anything about that now. Hopefully this genetic analysis of the potential organisms that we find would be able to let us distinguish between which ones have come from Earth and which ones hadn't, or at least on what time frame, and whether it was in the 70s or some few billion years ago when a meteorite landed there. But yeah, we would not be living in areas where this liquid water has been seen to be seeping up. So 2015 Nature articles are that brine water is periodically, seasonally emerging on the surface of Mars, creating these kind of black marks. So we would not be living anywhere near there. We'd be living somewhere in between the North Pole and the equator, around 45 degrees, because there's more H2O near the pole, frozen there, but it's warmer near the equator, and in an area which has not had anything interesting in terms of potential search for life. So this is very vague, but people are discussing these things at length.
Mr. Ritchie, sir.
Is procreation envisaged on Mars? And if so, will the first child be a Martian?
Yeah, so there are some candidates thinking about that, so I think that's not really on my agenda. I'll be looking for life and not trying to make it, but I think, I don't think people go to Antarctica to start a family, really, so I think if you wanted to go to Mars and start a family, you would raise eyebrows in the same way as if you wanted to do that on Antarctica, but it's possible, why not? If we wanted a self-sustaining society on Mars, of course, that would be the future goal. But I think then we can look to genetics and the distribution or genetic diversity required to have a viable, healthy population is in the hundreds, depending on where you look. So I think once we have a population of a few hundred, we could start to think about that. But I think unlike on Earth, where it's a human right to reproduce, on Mars it will most certainly not be. It will be a decision made by the whole community, because that is a very serious introduction into that environment, a new life. You would need to have an education system in place, guaranteed resources for that person, and the best possible living standards available for them. And I think as adults, you might decide that the living standards are not what you would like to introduce a child into. And I think that'll be a very interesting discussion, but certainly one that would require a lot of depth. Of course, it's cheaper to bring, PhD engineers from Earth than it would be to raise them on Mars.
How will they handle old age?
Gracefully in the low gravity, hopefully.
But once you cannot contribute in such a situation, everybody needs to contribute 100%. It's almost like the survival programs.
Yeah, so I think the knowledge, so the Mars One project also hasn't put an upper limit on the age of the people who've applied. So let's say there's an 80-year-old Russian cosmonaut with 500 days in space. I would think that his knowledge and his state of mind that have enabled him to achieve that would be useful to the team regardless of his physical state. So of course if people start to lose the plot mentally, then that's another issue, but I think physical degradation is less severe in a lower gravitational field. So if they were staying inside the habitat, movement would be easier than it would be as a 80, 90-year-old person on Earth, if we're that lucky to get that far. But I think the knowledge of that person would be invaluable, and they would still be a very crucial part of the team regardless of their physical capacity.
But at some stage will you say, okay, this is now, we cannot sustain you anymore.
Now you become fertilizer for the greenhouse. I'm not sure about that. We'll cross that bridge when we get
Just like on Earth.
You mentioned 3D printing in space. And you mentioned printing of PC boards and so forth, components that is needed in space. Does these 3D printers already exist to the point that you can actually print substrates for electronic PC boards, monolithic ICs and so forth? Or is it still on the evolution path?
So I think circuit boards and so on, I think you can print. I don't think it's cost effective compared to the I'm sure the experts more than me on this, but I think it's not cost effective on Earth to do it by 3D printing yet, but it is possible. 3D printing processes and so on, I don't think that's been achieved yet. If anyone knows any different. But I think we're making leaps and bounds in that direction. So what they 3D printed in the space station there was really a plastic, hard, strong plastic, not very good engineering terminology, but that could be used as a wrench. So very basic first attempt, but I think the progress we're making in 3D printing is going to be exponential, as with many others. So in 10 years, we can wait and see.
The other one, you mentioned that the radiation is not that bad because of the atmosphere, but Mars hasn't got any magnetic field. How does that affect you? Yeah, so this is maybe not mainstream theory, but after my reading, this is kind of the theory that I'm settling on. So
Mars did once have a global magnetic field. How do we know that? From the ferromagnetic patterns and rocks that we find globally around the planet. So it currently does not have a global magnetic field. There are parts of a field that are still active in certain areas. So what happened that caused the magnetic field to fail? There is a theory then that it was a large impact. The asteroid belt sits between Mars and Jupiter, the highest density of asteroids. So it's possible that there was a big body, a planet, some say, and I hope I'm not going too far into the Agent Aliens YouTube videos I've been watching here. But this could be the case, that there was a body that impacted with Mars, shed that debris, which became the asteroid belt, and and disrupted the dynamo that would sustain the magnetic field on Mars. After the cessation of the magnetic field, the atmosphere begins to be stripped away with ionized particles coming from the sun, and this accelerates, and you end up with a planet that was above 0 degrees and had liquid water on it, with a planet that now sits at -50 because the atmosphere is not thick enough to keep in any heat. So that could be one way in which things had happened. This is, of course, interesting for Earth. What kind of event could cause our magnetic field to fail? The movie Core is a perhaps not so realistic assessment of what could happen there. But yeah, these are interesting questions. I think I haven't mentioned climate change either. So Venus used to have liquid water on the surface around 1 billion or 2 billion years ago. Now it's hundreds of degrees Celsius on the surface. That's called the runaway greenhouse effect. Mars used to have liquid water on the surface. It's now -50. So as our next door neighbor planets pose very interesting things to study in terms of understanding and having a means to compare our climate models here on Earth to for accuracy of prediction. So I think these are questions on a planetary scale that we so far have only one data point for Earth with any detail, and this is another reason why going to live on Mars could give us useful insights into the future of Earth.
Bongani.
You've said you will be having crews that will be sent every 2 years that will have to go there. So one of the assumptions will probably be that within that space of 2 years, the first crew has to send back some data so that the guys that are going to go after 2 years are better prepared or something like that. So in that regard, it means the first crew will have a certain objectives in their first 2 years. Maybe you can share with that. And the other question is that, in real life things happen. So what if the second crew does not make it in 2 years, but they are delayed by a year or 2? What will be the impact? Are you prepared for that?
So I think The Martian has given us all an excellent example. If you haven't watched it yet, I'm sure you're going to go and watch it now. It was written as a book first, and the author published chapter by chapter and put it up for public scrutiny. All of the computer scientists and the space scientists and everyone was criticizing and commenting. So the book that emerged after all of that feedback is really quite accurate. The movie, of course, took some liberty with the Hollywood sensationalization. So that book is quite a good reference point, so I do refer to it more than once because it was written in quite some accurate detail. So what would happen if the second crew didn't arrive? I think when we see all the scenarios of how you could piggyback on other space agencies' launches to launch a cargo mission containing food, we'd be growing the food in the greenhouse with as much speed as possible, using data to optimize the growth and to get kilojoules out of there, not just potatoes, but the full range of kind of nutrients that we'd need. We may have fish, we may have worms to get protein and to also help to run that ecosystem in the greenhouse. So I think there are several ways that we wouldn't starve if the second crew didn't arrive. The data to and fro from the crew that leaves first, of course, this will be crucial. So this is obviously the first time we will have done this. Lots of unforeseen things are going to go wrong, and we'll be in constant contact. So more than just sending data, we'll have... So during the moon landing, of course, equipment was primitive. It had the processing power of a Nokia 3210. So what we'll have now is, of course, much better communication systems where we'll be uploading video clips and video tutorials probably when something goes wrong that we didn't expect, to get really teams of experts to give a detailed video on how to fix different aspects, medical issues, electronic issues, etc. So, yeah, the first mission will, of course, be a steep learning curve, but generates a lot of knowledge, even if it doesn't succeed, for the crew that leaves next.
I like the whole thing that there's competition and a sense of urgency, because that'll keep the momentum going. But to lower risk and the unknown, wouldn't an extended phase of automated and semi-automated mission be preferable? I mean, say, we don't want to hear this, but postpone by 10 years and make very sure that everything is there adequately before humans arrive.
That's what my mom says. But it's a reasonable thing to say. She said, can't we send the humanoids? I was like, we don't have very good humanoids yet, but I mean, in 10 years' time, we may have comparable level astronauts to humans. But yeah, so the mission for us is to do research on the surface of Mars, and I think you can do robotics to cater for certain tasks, but to have a robot that can do all the tasks that a human would do is decades beyond our current capability, I would think. Also, we need to, so we'd be putting human life on the line to make a greater leap than we would be able to do if we did it stage by stage, automated. But I think the ultimate goal is, of course, to have a backup plan for life on Earth, to have a seed bank, a genetic database, a backup library of all the complexity that's emerged on Earth, as well as a group of humans there in the, disastrous case that something goes badly wrong on surface Earth. So the sooner we start to send humans there rather than remotely controlled missions, the better.
A simple question. Do you have any farmers in this top 100 of yours?
Certainly. So there's already a Dutch research group that's taking charge, or at least doing some research towards what kind of seeds we would grow there, looking at Martian analog sand. So far we've never brought anything back from Mars, but we've analyzed the surface sand remotely, so we can make analog Martian sand here and see which seeds grow better in it, maybe genetically modify them to grow better in that sand. These kind of studies are going on. So I think it's even more complex than just which plants grow well in the sand. It's what kind of ecosystem can you make there, and then we have permaculture or aquaponics with fish swimming to create the nitrogen necessary for the roots, and the roots suspended in water. There are all these different scenarios where you can introduce insects, worms, etc. into the mix to make as much of a self-sustaining greenhouse area as possible. But this is certainly one of the most crucial areas of research for the living standards and the survival of the crew, certainly. And yeah, farmers are welcome, green-thumbed people welcome.
Yes, please.
When Armstrong landed on the moon, he put down the American flag. What will it be in this case? It's a discussion.
Good. So, yeah, I mean, I did have a picture of a South African flag on Mars once to indicate that there were 3 candidates. So 3% with 3% probability currently it could be a South African that gets to Mars first. But this will be indeed a collaboration of all humanity, and I don't think there will be a place for any national flags on the surface of Mars, at least in my opinion. Perhaps we could get Earthlings to design us a new flag while we're en route, or maybe we'll be doing some doodling on the 7-month journey there. But I think the Mars One project has specifically sourced candidates from all over the world, and each team of 4 will be as much of a distribution of humans as possible, different continents, different backgrounds, professional backgrounds as well as cultural backgrounds. So it's really like a microcosm of Earth as much as possible that we send to Mars. So that kind of leads into legal issues, visas, passports, legal systems, and I think blockchain is an excellent way in which we can still get paid if we would like that while we're on Mars. Why should we not be able to support family members on Earth with a salary from a company that's still making money on Earth from our activities there? Cryptocurrency is a perfect way that we'd be able to do that. I think personal digital identity is a huge topic lately, and blockchain is one. Blockchain can be applied in this sphere too, so that every human, whether they're born on Mars or on Earth, will have some kind of identity associated with them, and that no matter what planet you're living on, you would still be counted in some way amongst humans. So, yeah, I think the legal issues and the so we'll drop nationality, I would say, but the legal issues then are interesting because currently the country that you launch from determines the laws that you need to abide to while you're in space. So there's an interesting transition when you're out of low Earth orbit, when you're maybe, not in international waters, but in sort of extraterrestrial waters. We need to devise what kind of legal systems we'd have there.
Nah. Okay, last one.
Is there any long-term plans to change the atmosphere of Mars so that it can become habitable?
Terraforming.
That's an interesting question. So a lot of science fact has come from science fiction, and terraforming is one of those proposals that came from science fiction that we're now starting to think about actually implementing, maybe more speculatively. Elon Musk has a plan for that, of course, and that would be to nuke the poles. So the white polar caps that you see on Mars do have some H2O in them, but actually it's mostly carbon dioxide. So you apply a lot of energy there. I'm not sure what he meant by nuke. I try to find detail on that. But apply a lot of energy to the poles, melt the carbon dioxide, create some kind of atmosphere. How you would maintain that atmosphere and how that atmosphere would be maintained in the absence of the magnetic field is something we have probably absolutely no knowledge of, only with our solar system planets to study. So how that would be maintained would be the question, but it would certainly keep in heat initially. And once you can raise the temperature on the surface to above zero, you can do what happened on Earth, the great oxygenation event, when cyanobacteria began to produce oxygen. That was 2 billion years ago on Earth. We could implement the same process on Mars and oxygenate the atmosphere by introducing large colonies of cyanobacteria into the liquid water that would then collect. As easy as that.
Ladies and gentlemen, I think you'll all agree with me that this has been an absolutely wonderful and an inspiring keynote. Thank you very much, Adriana. I would like to leave the last words to Carl Sagan, who in the modern era is the guy who really propagated the Mars mission. He said this, just before he died: "Whatever the reason you are on Mars, I'm glad you made it, and I wish I were there with you." That was his message to the Mars going. Adriana, good luck. Thank you very much indeed.
So much. Thank you.